Hey everybody, it's Ben here, and recently I've been working on converting a tractor to electric. This is a 1950s era International Harvester. It's the 300 utility, and I've already got the engine off of it. I stripped a lot of other parts off of it. The crazy thing with a tractor is you can't necessarily just take the engine out. So on this tractor, the engine is actually a structural member between the transmission and the front end of the tractor. So you have to literally split the tractor. That's one of the challenges that this project has. Kind of full disclosure thing, I'm not a country boy. I did not grow up on a farm working with tractors, that sort of thing. So this is actually my first real experience with a farm tractor. Another thing is we want to be able to have a clutch on this tractor. We'll come in close and I'll show you exactly why in a minute. But I've worked on a couple different electric vehicle conversions, but they've always been either clutchless or direct drive or something like that. So actually just putting a clutch in here is a little bit new to me. So what we're gonna do is come in closer, take a look at the transmission, take a look at the engine, flywheel, clutch, and talk about some of those weird little challenges on this project. So now we're looking right into the end of the bell housing off the end of the transmission. A couple of things here. First of all, this nice big hole back here. That's because the starter was on the transmission side, not the engine side. Might be a little bit different from what you might expect from just like a basic little hatchback manual transmission car. So if we come in close here, this is the driven shaft of the transmission, which is spun by the engine. But if you'll notice, it's floppy. It can kind of move around. It has to be supported by something. Normally, this tip would go right into a pilot bearing directly in the middle of the flywheel. So no matter what we do, whether it's a flywheel or a hard coupler or whatever, that has to be supported. Another thing here is back here is the throwout bearing. And just listen to this. That is a worn out bearing. That absolutely needs to be replaced. But where it gets really interesting now is that this isn't just a single shaft. We've got a shaft in the middle, and that goes through the manual transmission and it spins the rear wheels. But here we have this around the outside of that, and that spins independently. And what that does is that powers the PTO. So in the back of the tractor, there's a lever that engages the PTO, and I can actually activate that right now, and I can get in here tight and rotate this, and you will actually see the PTO spin. So now I'm going to take off the flywheel, but first we have to take off the clutch cover or the clutch pressure plate and the clutch disc itself. So the first thing you'll notice about this clutch pressure plate is that it has splines in the middle. It's not just applying pressure to the clutch. Those splines engage with that collar that goes to the PTO. So as long as the engine is spinning, power is being passed through to the PTO, and it can be engaged and disengaged with that PTO handle. Now, when we actually get this pressure plate off, what's interesting is you can see the plate itself is really big and hefty, and the reason why is it's not just holding pressure against the clutch, but it's also passing power back to the PTO. The clutch disc itself is more or less what you would expect from working on a manual transmission car. It's the grippy surface, and then in the middle it has the splines, which rotates the driven shaft in the transmission. And of course, this lets us control the power between the engine and the wheels so we can pull smoothly away from a stop. And in the case of this tractor, we need to have that so that we can pull away from a dead stop with the PTO already spinning. So I want to get the flywheel off. I've got my 3/4 inch socket on a breaker bar. We've got 4 bolts here that hold the flywheel onto the engine. But if I want to just try to go and loosen this, what's going to happen is we're just going to spin the whole thing. We're actually cranking the engine through its steps. But what I did find is that there's actually a couple of holes on the rim here that I think were designed to let out the kind of the brake dust from the clutch. So if I just take my big marlin spike here and I poke it in one of these holes, what's going to happen is it's going to stop right here, and that should be all I need to get this started. That's it. And then I can just pull those all out, just like that. Nope, and they're pretty solid. The flywheel was on there really tight, so I just tried to pry it while rotating it and slowly work it off, but make sure to keep it straight while I was doing that. Hard work doing that. Just try not to crush your fingers. Oh, God. And in pulling this flywheel off, I actually set it directly down onto a bathroom scale right away. Let's see if we can get our view in here. Looks like about 70 pounds for that flywheel. Not exactly lightweight. So there's the back of the flywheel, and we can see that machined surface there. So what I want to do now is figure out the distance between the front of the bell housing to the back of the flywheel, because I need to recreate that with the electric motor, whatever kind of a hub spacer, thingamajigger that I use to connect the flywheel, or some sort of flywheel replacement. So what I need to do is measure from this plate surface to this. Of course, they're off center from each other. So what I'll do is I'll put something rigid flat across here. Just use my speed square for that. And then I can use a digital caliper and measure down from there. Now I already fiddled around with this a bit, and I found out that that number is 1 1/3 inches or 34 millimeters. Since the flywheel was out of the way and I took that measurement, I could now pull out all the bolts that held the steel plate on and pull it off. Woo! Something to build an adapter plate from! Here is the clutch cover, and it's really big and heavy, but what's interesting is that it's also splined. So this would actually face this direction, of course, but this goes way back on just that outside collar, and that spins no matter what. Basically, as long as the engine is spinning, this is spinning. Whereas this part can be engaged or disengaged with the clutch. So we can have this always spinning, and then the clutch sits up on there, and that can engage and disengage. So those two shafts are actually independent of each other. So one of the other concerns is, because the engine itself was a structural member coming off of the transmission here, we need to replace that somehow. And the engine bolted onto these 8 main holes here, nice and sturdily. So what I need to do is I'm gonna have to design some sort of structure that comes off of there. I already made a simple template. I just took some cardboard, I put it on here, I found where the holes were, I marked the 5/8 and 1/2 inch holes, and then just cut it out, just have a lightweight, easy to carry around thing. And one reason for doing this is there are some other tractors out there that I believe uses the same faceplate bolt pattern. And I think I could get some frame rails off of one of those, something like a Farmall Model H, for example, I believe is actually going to fit that. And if I can just buy side rails and bolt them right on, half that structure work is going to be done. Those side rails also have some slots or holes in the side that'll be perfect for building some structure that will go around the electric motor, and then above it hold batteries. The other thing is that since I have the flywheel off the engine, it means I could pull this off. And what this was is essentially an existing adapter plate. I suppose it made sense in manufacturing to be able to put different transmissions or different engines together and just make a simple plate. This is 1/4 inch steel, and this bolted right up onto here, and then the middle of these bolt holes are where the engine bolted on. So what would make sense then is I can use this as a template in terms of where the bolt pattern is here. And what I'll have to do is essentially, whichever motor I want to use, figure out where its mounting holes are. Maybe that's something I could get plasma cut for me. Maybe it's something I could do with a CNC plasma cutter at the local makerspace. So certainly there are some challenges with this project, but at the same time, it's certainly been interesting. I've been learning about hydraulics and PTOs and all that tractor type of stuff. I do think having a clutch is the right way to go. The tractor transmission is very different from a car transmission, and I need to have a clutch if I want to be able to be using the PTO, have the tractor at a stop, and then smoothly be able to start spinning the wheels. What do you think? Let me know. Please like, comment, subscribe, share this with your friends, throw it out on social media. Check us out at patreon.com and at 300mpg.org. And until next time, stay charged up